Section 3.5, we're talking about real zeros of polynomials. So section 3.4, we did some of the factor theorem, the division of different things. We're going to be using that in section 3.5 to help us find zeros. And so we're going to talk about, first of all, what is called the rational zero theorem. So if we're given this polynomial, and again, this is just generic form of any polynomial, nothing really amazing about it, but just the idea is it's written in descending order. So your biggest power is first, and your smallest power, your constant, is last. It has integer coefficients. If r is a rational zero of f, so rational means it's a fraction of two integers. Okay, that's what rational numbers mean. You can write it as a fraction with two integers. It can be written of this form, p over q with a plus or minus in front. So p over q, p is going to be a factor of this constant term from the very end. And we'll practice this, but the q is going to be a factor of the leading coefficient at the very beginning. So we're going to start out, we're going to identify those terms. And I think we talked about the leading terms previously and the degrees previously, right? So we're going to be using that for the leading term. And then we also want to talk about the constant. I guess I haven't checked this yet, so hopefully this is going to work. All right. So let's take a look at example 2 here. It says let f of x equal 2x to the fourth plus 4x cubed minus x squared minus 6x minus 3, and use the rational roots theorem to list all the possible rational zeros. Okay, so we're not actually going to figure out what the zeros are now. We're just going to write down the possibilities. What could happen? Okay. So what we want to do is when we see this phrase, the rational root theorem, we want to think that we're talking about p over q. Okay, we're talking about a fraction. And these numbers on the top, which we call p, have to be factors of the constant term, which is right over here, the 3. And we don't worry about the negative because we're going to put in a plus or minus anyway. So we don't worry about the fact that it's a negative 3. We just say factors of 3. Okay. On the bottom, the q, and we'll talk about those factors in a second, but the q comes from factors of the leading coefficient, which is that 2. Okay, so these are the two numbers that we have to focus on. So let's write down what are the factors of 3. What numbers divide into 3 evenly? 3 and 1, right? So 1 and 3. And I'm just going to write those down on the top. So those are the numbers that could be on the top of our fraction. And then we want to do the same thing on the bottom. What are the factors of 2? Just 1 and 2. So then what we have to do is we have to make all the fractions that have a numerator on the top of 1 or 3 and a denominator on the bottom of 1 or 2. So here's how we do it. We just start listing these and we say, okay, we could have 1 over 1 and 1 over 1, that's just 1, right? We could also have, so I'll put a comma, we could also have 3 over 1, and 3 over 1 is just 3. We could also have, so that takes care of a denominator of 1. We've used the denominator of 1 for both of the tops. But we could also have this 1 over the 2. So we could have 1/2. And then we could also have the 3 over the 2, which would be 3/2. And so now we've done all the numbers on top as numerators with all the numbers on bottom with as denominators. Does that make sense? And the only thing we have left over is each of these could be a positive or a negative. Okay. Now, just a little side note as far as your homework. Usually on the homework, in front of your answer box, it'll put a plus or minus, and then your answer box. So you would just have to put the 1, the 3, the 1/2, and the 3/2. If that plus or minus is not there, there's no way to do plus or minus. So you just have to list 1, comma, -1, comma, 3, comma, -3. You just have to list them all out. Okay, does that make sense? So if the plus or minus is there, you're taken care of. You just write them down. But if that's not there, you have to do each one separately. Okay, so I know that I've had some students who run into some trouble there because they're not sure how to write their answer, even though they know what the answer is. Okay, but does that process make sense? How we write down the possibilities of what could be a rational zero for this function, using that what is called the rational zero test, using the 3 and the 2 in this case. Okay, any questions there? All right, so these are our answers, and the order that you write them in doesn't matter. I just happen to do them kind of the same way every time, so that's how I wrote my answers. All right, so the next thing that we're going to do is, notice this is the same polynomial. Right here is the same as this one. Okay, same polynomial. But now what we're going to do is we're going to find the horizontal intercepts, or the x-intercepts, which means we're going to do this. We are going to set this equation equal to 0. That's how you find the x-intercepts, right? You set that function equal to 0, and now we're going to solve this equation. Okay? So here's how we do this. Our first option is, can we factor it? Because if we can factor it, that's much easier than the method we're going to be using now. Because the method we're going to be using now is really, honestly, we don't like to do this in math, but this is a guess and check method. Okay, we're just guessing and hoping we come up with the right answer. Now, the rational zero theorem gives us these 8 numbers to choose from our guessing. So we only have to worry about choosing and guessing from these 8 numbers instead of, all the numbers in the whole world. But we're still guessing and checking. Okay. So what we're going to do is we're going to, first option is factoring, but this has 5 terms. We don't have any way right now of factoring 5 terms. Okay. So what we're going to do is we are going to just start guessing and checking from these numbers. And I'll just tell you my strategy when I do guess and check with these sorts of things. Usually we're going to do synthetic division, and we'll put down our 2 and our 4, -1. These are going to be in my way, -6. I'll just erase them. You guys can remind me what these are. -3. I'll put them here. Okay, so this is our polynomial that we're going to divide. Okay. And what we do is we're going to use synthetic division to test these. And I know it's been 2 weeks, but to go back 2 weeks and remind ourselves, we did something at the very end of class last time called the remainder theorem. Okay, and the remainder theorem told us if we do our synthetic division and we get a 0 right here, then whatever this was is part of a factor of this main polynomial. Okay, which means it divides into it evenly. And that's what we're looking for. What can divide into this evenly? Okay, so our goal is to pick something where this last number, the remainder number, is a 0. If it's not a 0, we're going to go back and try again until we can find one where it's a 0. Okay, so I'll just tell you the first thing I always check is 1, and that's because there's a little bit of a shortcut for 1. And 1 is always one of our options, so always check 1 first. But here's the deal with 1. We're not actually going to do the synthetic division. Here's what we're going to do. The shortcut for 1 is if we add up all these digits, all these numbers, and they equal 0, then 1 will work. Okay? 1 will be one of our zeros. So if we add these up, do we get exactly 0? No. So right away, without doing that, I know 1 is not going to work, and I'll just cross off the 1. Diana, did you print off the notes yourself? You have them? Okay, otherwise I have copies here if you need one, but if you've already got them, then I won't worry about it. Yeah. You've got them? Okay. Okay, so we're not going to try 1. And I'll tell you, I usually like to stay away from the fractions until I have to use them. Okay, so let's try, and I usually like to stay with the positives. The method I'll do is I'll take my nice positive numbers and try those, and then I'll maybe go to the integer negative numbers and go with that. And hopefully we find it before too long. So I'm going to go with 3. So remember the process. We bring down the 2. 2 times 3 is 6. 4 plus 6 is 10. This is going to be way too big. I can almost see that already, but let's double check. 3 times 10 is 30. 29. Yeah, okay, so this is going to be way too big. 3 is not going to work. So we're going to cross off positive 3 also. Okay, Leslie, did you have the notes already? You were here 2 weeks ago, right?
Yeah.
Okay, so you got them. So unfortunately, like I said in our guess and check, 3 is not going to work. So we just go back and we start over again. So 1 is gone and 3 is gone. I don't know. What do you guys want to try next? I usually just let my classes choose and then we just go through it. There is right and wrong answers, but it doesn't matter for what you choose. It doesn't matter. So what do you think? Anybody want to pick one? You know, good at guessers you are? I don't remember what the answer is, so. All right, well, if you're not going to guess, let's just try -1. All right, 2 times -1 is -2. Add that, we get 2. Multiply again, we get -2, -3, which gives us +3, -3. Hey, I think I got that one to work. All right, so -1 works. And the reason it works is because you end up with a 0. So here's what that means. Remember, if that's the number we used, x plus 1 is the factor. And then what's left is this. Remember, the degree always goes down by 1. So this would be 2x cubed plus 2x squared minus 3x and minus 3. So it's basically like we found a factor by doing this division. Okay. Now here's another kind of strategy that I use. If I find something that works once, I usually try it again because sometimes these answers occur more than once. So I'm going to try -1 again. And I'm just going to continue going from where I was. I'm not going to go back to the beginning. I'm just going to keep going because our goal is to keep breaking this down as far as we can. Okay, remember how we did our synthetic division and we break it down little by little? I think we did this also 2 weeks ago. But we break it down, and we want to break this thing down as far as we can. So let's try the -1 again. We bring down the 2. Multiply, you get -2. That adds to be 0. Multiplies to be 0. Adds to be -3. Multiplies to be 3, and adds to be 0. So that one works again. So what that means is we have the x plus 1. Then this broke down into x plus 1 again with 2x squared minus 3 left over. Okay, does that make sense? Because this one was x to the 4th. Power goes down by 1, so now it's x cubed. Goes down by 1 again, so now it's x squared. And so every time you divide, that power goes down by 1. Okay, so now we're to this point, and we have these factors. Okay, do you remember what we do with each of these factors?
It's like 1 equals 0, and then
yeah,
same, and then
yeah, each factor gets set equal to 0. Now these two we don't really have to do because we already know that's these two. So x equals -1 and x equals -1 is the first two, this one and this one. They're the same. Then this one, 2x squared minus 3 equals 0. So what would we do to solve that one? What would we do first? Remember, our goal is to get that x by itself.
so now when we add
We're going to add 3. And so when we add 3, we're going to have 2x squared equals 3. Then what? Divide by 2. So x squared equals 3 halves. And what's our last step going to be? How do we get rid of that squared? We take the square root of both sides. Yep. And remember when we do that, I know it's been 2 weeks and we've been doing stuff, but when we do that, we're going to put in a plus or minus in the front because we have not only the positive, but also the negative. Okay. And I'm not going to worry about simplifying this right now because I think in the homework, they just let you divide it and turn it into a decimal number anyway. But what I do want to do is I want to make sure we write the answer correctly because they're asking for the x-intercepts. And remember that x-intercepts are points on the graph. So for these two, we're going to have x is -1 when y is 0. Those are the x-intercepts for these two. Okay. Then for this one, we'd have the square root of 3 over 2. That's not very big, comma 0. And negative square root of 3 over 2, comma 0. So these are the x-intercepts that we have for that problem. And again, we could worry about simplifying the radicals. I'm not going to worry about that right now because, again, you can usually just, the calculator or the computer accepts it if you just turn them into decimal numbers. So what questions do we have on that? So we're using that synthetic division that we learned 2 weeks ago to help us with finding zeros now using this rational zero theorem. So remember, the rational zero theorem gives us the possibilities, and we just start checking them. And once we find some that work, then we don't have to worry about those possibilities anymore. We can, once we get down to quadratic, x squared, then we can factor or just solve it or use the quadratic formula. We have, once we get down to quadratic, we can solve it. We don't have to guess and check anymore.
I know we use -1 because we had it on the first example, but on any other stuff, we just
have to start picking. Like we tried 1, didn't work. We tried 3, didn't work. We tried -1, and then finally on the third try, we got one that worked. So you may you may guess it the first time, or it may take 5 times before you guess it. That's why we don't like guess and check, because we're just, we're guessing and just hoping that it will work. So, but yeah, you might find it right away, or it might take a while, which is why we don't like to have to do that. If we can factor and solve it that way, we would much rather do that because we know how to factor already. So, what else? Yeah, so I guess going through this, the guess and check, we guess and check until we get down to quadratic. And once we get down to quadratic, then we just solve it, either by factoring or quadratic formula, or in this case, just solving to get the x by itself. Okay, so the answer here, like I said, will probably look a little bit different because I turned it into a decimal number. So here's your square root of 3/2, so these two, and then the -1. Okay, and again, the reason we write it like this is because they asked for the x-intercepts. If they asked for just solve the equation, you would just say x equals -1, x equals -1, and then these. You don't need the order pairs in. So same work, but you're giving your answer in a different way. All right, let me get rid of this, and we're going to do the same thing. So notice this one is worded a little bit differently. They're not asking for x-intercepts. They're just saying to find the zeros, but we're going to actually do the exact same work. So to find the zeros, we still just put equals 0. And we don't worry about that anymore because it's equal to 0, and we solve this equation. That's what zeros are. So when does this equation, when does this function equal 0? So this one has 4 terms. And you may remember when we did our factoring, we could do factoring by grouping possibly if it had 4 terms or an even number of terms. So let's take a look and see if we can do factoring by grouping here. What can we take out of the first group? A 2 and an x squared. That's correct. And that leaves us with 2x minus, dividing that out, we'd have 5. Then we have to take out the negative. And what can we take out of the, what else can we take out of the second group? Oh, Myra, do you have the notes? Okay, let me get you the notes. Did anybody else not have the notes? You don't have the notes either. I saw you guys come in and I just kind of checked out mentally and forgot that you guys wouldn't have those. I apologize, they're kind of upside down, some of the pages, so they got copies, they got one, so. So what else can we take out of that second group? Besides the negative?
2.
A 2. So when we do that, what do we have left? When we divide by -2, we're going to have x, and 2 divided by -2 is -1. So remember, this one is not going to work because these aren't the same, right? When we do it and factoring by grouping works, these two factors have to be the same so that we can pull them out. So we can't do factoring by grouping. we've got to go to our guess and check method, which we don't like to, but we can't factor it. So we're going to go to that. So that means we're going to do P over Q. And P comes from the factors of what? We'll test your memory from a little bit ago. Factors of this 2 right over here at the end. So factors of 2. Let's go ahead and write them down. What are the factors of 2? 1 and 2. The numbers that divide into 2 evenly. 1 and 2. Okay, let's switch colors. And we're going to do factors of what on the bottom? The 4, the first number. So they come from right here. The leading coefficient, it's called. So what are the factors of 4? 2 goes in there. What else? What else divides into 4 evenly? 4 and 1. Right? Does that make sense? Each of those goes into 4 evenly. So then we just put down all of our different groupings. So we could have 1. I'm going to start with 1 over 1. So 1 over 1 is 1. 2 over 1 is 2. Right? So that takes care of a denominator of 1. Then we can have 1 over 2. Right? We could also have 2 over 2. But what do we know about 2 over 2? It's 1, and we already have 1, so we really don't need to write that again. Does that make sense? You don't need to put it in the list more than once. So that takes care of the 2 as a denominator. Then we could have 1 over 4 and 2 over 4. But what do we know about 2 over 4? It's 1/2. So that's already in our list also. So we don't need to write that one again. We're going to have these. And then remember, we're dealing with the positives and the negatives. Every one of those gets a plus or minus in front. So we have 8 possibilities to choose from. Okay, that we're going to possibly have to check. So let's go ahead and set up our synthetic division to check these. We've got 4, -10, -2, +2. And you may remember I said I always check 1 first, but there's a shortcut. So the shortcut is, remember, if we add up all these numbers and we get 0. If we add up all these numbers, do we get 0? Four plus -10 plus -2 plus 2. Nope. So that means 1 is not going to work. So we're going to cross off +1. All right, I'm going to let you guys choose now. Who wants to pick the second number? I mean, we checked 1, but we didn't do anything with it. So. And I don't care what you pick. 2? All right, we'll pick 2. All right, so we drop the 4. 2 times 4 is 8. That goes there. We add that. We get -2. -2 times 2 is -4. Add those, we'll get -6. -6 times 2 is -12. And that's -10. So it's not a 0. So 2 doesn't work. 2 is not a 0. In order for it to be a 0, it has to come out to be 0. Okay, so back to the drawing board. 2 didn't work. I would make sure you have some scratch paper when you do these types of problems, because you don't want to spend 5 erasers just erasing things if you ever don't get it. So who wants to pick the next one? Somebody quickly, it doesn't matter.
-2.
-2. All right, let's try it. -2. So drop the 4. We get 2 times that is -8, and that'll be -18. That makes +36, which is 34, and -68. So that one does not work either, right? So now -2 is also gone. So we've gotten rid of 3 of the 8. Somebody pick another one for us. -1. Okay. So -1. Drop the 4. Multiply, we get -4. And that gives us -14. +14. 12. -12. -10. That doesn't work. So -1 is gone. Uh-oh, we're down to fractions. All right. So forget those. And again, we're looking for the 0 at the end, right? That's what we're looking for. So somebody choose another one. -1/2. So that's 4 times -1/2 is -2. This is -12. This will make 6, which gives us 4 and -2. Hey, that one worked. Okay, we got a 0 at the end. So x equals -1/2 is one of our zeros. I don't know if you remember this, but the total number of real zeros could be possibly up to 3, right? What that degree is, that tells us how many zeros you could have. So in that last one, we actually had 4 if you counted the -1 twice, because it happened twice. But now we've simplified it down to this. And notice this was x cubed, so this is 4x squared minus 12x plus 4. And we're trying to still find out when does it equal 0. Once you get down to x squared, you don't have to do guess and check anymore. We just solve it, either by factoring or by quadratic formula. Okay? So looking at this, and I don't know how much we've talked a lot about this, but do you see how these all have a common factor? What divides evenly into all of these? 4. Now, we could factor it out, but with an equation, we can just take both sides of the equation and divide everything by 4. As long as we do the same thing to both sides, that's okay. So dividing by 4, we'll have x squared minus 3x plus 1, and still 0 on the other side. 0 divided by 4 is still 0. So now we could try to factor. Remember, we take 1 times 1, which equals 1. Since it's a positive, we know our signs are the same. So both positive or both negative. This would tell us they're both negative. But we have a problem. It would be -1 and -1, but that doesn't add up to be -3, right? So if we can't factor it and it's quadratic, we go to the quadratic formula. Okay? So let's remind ourselves about the quadratic formula. I'm going to write this up a little higher because I think I'm going to need more space. So x equals -1/2. Here's the quadratic formula. If it's not in your notes, you may want to put it back in there because you're probably going to need it sometime during this lesson. So the formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, and then that's divided by 2a. So there's your quadratic formula. Looking back at our equation, what is the a value? Yeah, it's this number in the front, so there's nothing there. It's automatically a 1. And the b value is -3. And then the c value is also 1. So let's start plugging this stuff in. X equals the opposite of b. So the opposite of -3, I'm just going to write this down initially, plus or minus. And then inside we have b, -3 squared, minus 4 times a, which is 1, times c, which is 1. So we've got 2 1s there. And on the bottom, we have 2 times a, so 2 times 1. So now that we've got all the blanks filled in, we've just got to start simplifying. What's the opposite of -3? +3. Plus or minus. Here we have -3 squared. -3 times -3 is 9. And then minus, and 4 times 1 times 1 is 4. And then 2 times 1 on the bottom is 2. And then simplifying inside that radical again, we just leave the 3 alone. And we leave the 2 alone, but 9 minus 4 is 5. Can we break down the 5? No, we cannot. Okay, so the 5 can't be broken down. And again, we've got one answer up here. The 2 answers we're going to get here are 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. That's what that plus or minus does. You have to write 2 answers, and the only thing you switch is one time it's a plus and one time it's a minus in between the 3 and the square root of 5. So these right here are our 3 real zeros. And again, I think the computer allows you to turn that into a decimal number and approximate it. This would be the exact value, but if you're going to do that on the calculator, you just have to do 3 plus square root of 5, hit enter, and then divide by 2. Okay. Questions on that one? Is that making sense? I know it's been a long time, so it seems like we've been gone forever. 2 weeks. All right. So yeah, the approximate values here for these two, 2.618 and 0.382. So you can turn those into decimal numbers on the computer, and that's fine. All right. Before I erase this, any questions? Last chance. Okay. Looking at this one, again, find the real zeros, right? Just a quick beforehand, how many real zeros could we possibly have in this case?
3.
3, because why? Yeah, the degree is 3, right?
Yeah.
The degree is 3. So right here, this tells us we could possibly have 3 real zeros. That's what it tells us. Okay. So again, we're finding zeros. We're just going to set this thing equal to 0. And there are 4 terms again, so I would try to do the factoring by grouping. So let's take a look. Factoring by grouping, what can we take out of the first group, the first pair? X squared. And what does that leave us with? Here we'd have 3x. And if we're dividing out x squared, we're going to have 1, right? X squared divided by x squared, or a negative x squared divided by x squared. Remember here, we have to take out the negative sign. What else can we take out of both of those? A 2. And when we divide by a negative 2, what's left here? A 3x. And when we divide this one by a negative 2, what is that? Negative 1. So we can factor by grouping this time, right? Because what can we take out of both of those now? We can take out the 3x minus 1. What's left? X squared minus 2. Correct. X squared minus 2. Now we've got it factored. What can we do with each factor? Set them equal to 0. 3x minus 1 equals 0, and x squared minus 2 equals 0. For this first one, what do we have to do to solve this? Add 1. And then what? Divide by 3. So one of our answers is x equals 1/3. On the second one, what are we going to have to do here? Add 2. And then what? Take the square root of both sides. That's right. X equals. Now, what do we have to do anytime we take the square root of both sides? Plus or minus. So plus or minus square root of 2. We can't break up the 2 at all. So our zeros would be, and again, this is kind of how it looks in your homework, you'll put in 1/3, you'll put in square root of 2, and you'll put in negative square root of 2, just separated by commas. Okay, so you'll list them all in one box like that. Okay, wasn't that a lot easier than having to guess and check? That's why we don't like to guess and check unless we absolutely have to. So if we can, I mean, now if you would have done the work, if we listed these out, P over Q, P would have been factors of, somebody help me out, factors of what? Where would we get that? The 2. And Q would have been factors of the 3 on the front. So 1 and 2, 1 and 3, that would be 1 over 1, that would be 2 over 1, 1 over 3, and 2 over 3, plus or minus. Notice this one right here. It was in our group, right? We would have found it eventually, right? But it may have taken us a while. Does that make sense? So it would have worked. We would have found it. But if we can factor it, it's going to be a lot easier for us, or quicker. Maybe not easier, but quicker. Okay? Does that make sense? So again, I know that we learn about this guess and check method, this rational zero test to help us out, but really we don't want to have to use it if we can help it. Sometimes we just don't have an option. Okay? Any questions on that one? Does that make sense? So it would have worked. We would have still gotten those same exact answers. It just would have taken us a little while to get the 1/3 probably. All right, and that is the end of 3.5.